Newton's second equation of motion. From the first equation of motion, we derived v, which is equal to u plus at. So where v stands for final velocity, u stands for initial velocity, and a for acceleration, and t for time. Now let us move to Newton's second equation of motion. And in the beginning of the lesson, when I started explaining Newton's equations of motion, I told you that Newton's equations of motions only useful for uniformly accelerated motion, right? So if it is non-uniformly accelerated, then we have to use integration, same way we are deriving here. Now if you look at this picture, consider one object moving with initial velocity u and moving in a straight line with uniform acceleration, right? And after t second, its velocity is becoming v, right? So the initial time is t and final time means for the calculation the time is t, right? So then we know that if you want to find out its instantaneous velocity, so instantaneous velocity v, which is equal to ds upon dt. This is instantaneous velocity. If you want average velocity, so the average velocity is total displacement upon total time, right? This is your average velocity. And when you talk about instantaneous velocity, so instantaneous in the sense when the displacement for a short time. Okay, when the time approaches to zero, then we know that. Yeah. So in this equation, can I write in this form ds which is equal to v dt? Answer is yes, we can write in this form. And so for this, in case of v, we know that from Newton's first equation of motion, we found v which is equal to u plus at. Right? If I substitute this value in the place of v, so if you see this v, so then if I substitute, so then can I write in this way? Yes. So then ds which is equal to u plus at dt, right? Now let us move for integration. Yeah, from first equation we found all these things. Now let us move for integration. We will start integrating for velocity. We will start integrating from u to v, and for time we will use 0 to the limit we will use, right? So then if you do the integration for displacement, we are going to find out displacement from 0 to s, and for time we start from 0 to t. This is the limit or the range for the integration, right? So then if it is ds, for integration of ds means small displacement. If you add small displacement, so after the time it is becoming complete displacement, the total displacement. So then this is your s. Then here, so the integration for u and also integration for at. So integration for all the terms, right? So then after doing all this integration, we found s which is equal to ut plus half at square, right? So let me write one sentence for you here. Can I write here? Yeah. So the same thing I want to write here, which implies, so the integration of ds will be s, and the range is starting from 0 to s, and which is equal to integration of u dt, the range is from 0 to t, then plus integration of at dt, the range is from 0 to t, right? So in the second sentence, so then this, for this integration, so the range is from 0 to s. So the next step I can write s minus 0, which is equal to, you can see here, u is the initial velocity. Then we are doing integration for time. So then integration for time is what? 0 to t. Or directly I can write ut plus the next one, acceleration is the constant. So then if you are doing integration for t, power is increased by 2 and divided by 2, and the range is starting from 0 to t, right? So then after that, the next step is here. Then we got the final calculation, s which is equal to ut plus half at square. So this is the derivation of Newton's second equation of motion, right? If you have any question, please write in the comment box so that I can answer to your question. Otherwise, let us move to third equation of motion, the third equation of motion.